we have some division to do of complex numbers. And when you have to do this sort of thing, it's much easier to work in polar coordinates instead of rectangular coordinates. So that's what I'm showing right here. First, you have to convert your rectangular coordinate complex numbers into polar form. I'm going to assume you're fairly comfortable with that already. If you're not, you should really go back and watch some of the previous videos on this topic. But just as a quick refresher, this is what I'm going to do. First, I have my general formula in polar form right here. And then I'm going to find the modulus of w using the square root of a squared plus b squared. And then the angle or the argument of w using the inverse tangent of the imaginary part divided by the real part. Okay, and you can see me doing that calculation right here. Now, when you eventually get two angles, that's normal, right? Sometimes you only get one angle, but often you'll have two angles for the inverse tangent. You must select which one of them is appropriate. So if you look at where your point is located, using those rectangular coordinates, you can plot it and see that it's in quadrant 3. Well, pi over 3 is not in quadrant 3. 4 pi over 3 is in quadrant 3, so that's the angle we're going to use, and that's why you can see I have 4 pi over 3 in my answer right here. Okay, so that's how you convert things to polar form first. Now let's move on to solving this problem. I'm going to focus on this guy first, w over z, because I think that's a little more straightforward. We have a formula for it right here. And all you do is you plug everything in that we already know from up top. We're going to plug that into our formula down here. So the modulus of w, for example, is 6. The modulus of z is 1. The angle of w is 4 pi over 3. The angle of z is 7 pi over 6. And we're simply going to do that same exact thing for the I sine portion. Okay, you again have 4 pi over 3 minus 7 pi over 6. Okay, so my writing's getting a little sloppy there. And now you simplify. This is your answer. We can clean that up a little bit, right? You could say what 4 pi over 3 minus 7 pi over 6 is, right? I think that's going to be like pi over 6. So you could write this a little cleaner. But essentially, this is how we use the formula. Now, at this point, a lot of people say, yeah, I get it. But what about, like, what am I supposed to do with this? With that 1 divided by w? What is 1? It's not a complex number. It's just the number 1. Well, it actually is a complex number. And you can write it this way. You could say the number 1 equals 1, right? That's its modulus, times the cosine of the angle. Now, what angle is associated with the number 1? Well, if I were to plot 1, it'd be right there, right? It's on the real axis. That's an angle of 0. Right? 0 degrees, 0 radians, however you want to call it, plus I sine of that angle, 0 degrees or 0 radians. Okay, so this is really what the number 1 is. And now you can do the division the same way as we did that last one. It's actually a little easier. Because look what we're going to get. 1 over w is simply going to be 1 over 6, right? Times the cosine of 0 minus 4 pi over 3. So it's the angle of the real number 1 minus the angle of w. And then we do the same thing for I sine. Okay, 0 minus 4 pi over 3. So this is how you do 1 over w using the quotient formula. I want to show you a shortcut now. Using the product rule instead of the quotient rule. What is this thing really? If I were to use an exponent, it'd be this. I said the product rule, but I meant the power rule. We're going to use the power rule here. If you remember what the power rule formula says, it says that the way you calculate this thing is you simply raise the modulus to the same power, okay? And then you have what's inside here being angles multiplied by that -1, or the exponent. So this becomes -1 times theta w plus I sine times of -1 times theta w. Now, if that had been n, we often see n instead of -1, then it would have been n times theta and n times theta for each of these arguments. But because it was -1 in this case, I have -1 right here, -1 right there. Okay, so now if you carry through what is going to happen here, you'll see that it turns out to be exactly the same as what we've calculated above. W to the -1 is simply 1 over 6. Cosine of -1 times theta is what? Well, it's negative times 4 pi over 3, which gives you exactly the same as what you have above. And likewise for the I sine portion of it. Now, I prefer this method because I think it's a little bit quicker, but you can do either one. They're both great.